Okay, this will be our fifth example. So we'll cover the design of singly reinforced beams. So how will you design a singly reinforced beams? So design problems is different from analysis because it's just a reverse. So ang gagawin natin is meron yung loadings, titignan mo ngayon yung appropriate number of or appropriate area of reinforcement to counter that loading. Okay, so ang gagawin natin, what will be, ang gist nito is what will be the area of tension reinforcement. These questions A and B are just complementary. Okay, there are three possible ways to solve for area of tension reinforcement. The first is using the mechanics. Okay, so we'll be deriving we'll be calculating the area based on mechanics. So let's start with the first question. What is the moment due to the factored load? Okay, this will be our solution. Okay, for the first part, okay, we need to calculate or we need to plot. Okay, we have a simple span of 4.5. So we have here a simply supported beam. So we have a dead load of ang dead load natin. Self weight is included. We have 20 kilonewton okay, per meter. And then the live load is live load okay 35 kilonewton per meter. And then we have pag simple support, a combination of uh, hinge and roller. So this will be 4.5 meters. Okay, so wait lang, ilabas ko lang yung calculator. 991ES para may pag-calculate tayo. Okay. Close ko lang to. So, yun. So, meron tayong loading. Kaya lang, these are the service loads. Okay, service loads yan. So, gagawin natin siyang ultimate. So, a combination. Pag combination of dead load and live load, okay, uniform kasi yan. So, let's say the ultimate combination will be 1.2 dead load plus 1.6 okay, live load. Okay, so kunin mo natin yung ultimate load combination. So, we have 1.2 multiplied by 20 plus 1.6 of 35. So, yung ultimate uniform load natin will be so 1.2 multiplied by 20 plus 1.6 times 35. Okay, so we have 80 kilonewton. Okay, 80 kilonewton per meter. So, ultimate na to. Okay, so now the moment for simply supported beam, ang maximum moment, okay, MU max is nasa yung kung ipa-plot natin to, so we have simply supported beam. So ito na yung WU. So yung moment dito is i-drawing natin yung moment diagram. Ganito yan. So nandito yung parang pinaka-maximum moment. Okay? So, yun, nandito yung, or yung highest moment all throughout. So, ang gagawin natin para safe, kasi you can also, merong every point nito, merong moment individual. Let's say M1, M2, and then we have here the peak moment. Okay? Or yung maximum moment due to ultimate load. Now, kung i-design mo yan, okay, let's say gawin mo ng uniform para at least sa detailing, simple lang yung detailing. Ang gagawin mo, whatever the expected maximum load, yun na rin yung design mo all throughout the section. Kasi kung dinesign mo siya at MU, ibig sabihin, since yung moment dito na point is less than MU, makikerry niya yung load or makakayanan yung load. So, ang MU natin for simply supported beam, ang ultimate load natin is WL squared over 8. Take note, ultimate na to. So, ang makukuha nating moment dito is also ultimate. So, your MU now will be, we have W, we have 80, and then L, a simple span of 4.5, A squared over 8. So, ano yung MU? So, solve natin ngayon yung MU. Okay, we have 80 WL squared, so 80 times 4.5 squared over 8. Okay. So we have 202.5 kilonewton meter. So this will be the answer for letter A. Next, depth of compression block. Okay, for the depth of compression block, so meron na tayo, di ba meron tayong moment dito? Okay, we have no nominal moment. Okay, nominal. Now, since yung basic design principle natin, we know that the VMN should at least equal to or greater than the expected load. Okay, ito yung design strength of the section, ito naman yung bubuhatin. Kumbaga, the design strength of the section should at least equal or greater than the expected load. Okay, para safe yung design natin, ang gagawin natin, the VMN, okay, i-equate natin siya sa MU. Okay, so meron na tayong VMN. Now, the problem is, ano yung gagamitin mong formula? So, meron tayong formula for MN. So, yung C considering T, so we have Fs, we have D minus A over 2. Okay, in this formula, we have As unknown to, di natin alam. Okay, unknown. Fs, di natin din alam kung mag-yield o hindi. And then we have also A here. So, in one equation, we have 3 unknowns. So, hindi natin pwedeng gamitin to. Hindi yan pwede. Okay, how about yung isang formula na Mn? Yung isang formula, which is ito, so 0.85 F prime C AB D minus A over 2. Tignan mo kung ano yung unknown. Itong B given yan. Itong D given din. Ang unknown lang dito is A. Okay, so ang unknown lang dyan is A. So, ito ang gagamitin natin. Okay, so ito yung gagamitin nating formula. So that your VMN or MU na ngayon is equal to V multiplied by MN. Yung MN natin is 0.85 F prime C AB D minus A over 2. Ito yung true mechanics. Okay, using mechanics to solve for the AS. Now, next problem natin, what will be the reduction factor? Reduction factor. Okay, before we proceed to the reduction factor, I'll just, meron lang akong i-explain na part, basic principle. In ganun kasi, in NSCP 2001, so meron tayong 3 types of failure. Okay, yung types of failure, let's say ito yung beam natin. So let's say naglagay ka ng AS. Okay, some of the one failure natin is yung AS mag-yield in tension before the concrete crashes in compression. We call that as tension failure. Okay, tension failure. Okay, in tension failure, they still yields before the concrete crashes. Okay, so yung tension failure natin nasa as much possible nasa tension control siya. Okay, so ano ba yung ang nangyayari sa tension failure? So meron tayong large deformation. Okay, large deformation sa beam. And then when you have large deformation, nagkakaroon ka ngayon ng parang tensile cracks. Okay, tensile cracks sa beam. And then when these tensile cracks propagate, magkakaroon tayo ng parang collapse. Okay, pag nag-increase pa yan, magkakaroon siya ng collapse. Okay, so next, let's say itong AS natin. Okay, ito yung tension failure. Yung next naman na design is ito, yung AS balance. Okay, yung AS balance, ang failure nito is yung tension steel, yung AS yield, okay, at the same time yung compression concrete crashes. Okay, sabay magpe-fail yung yung reinforcement natin and the concrete. Okay, we call this as the balance failure. Okay, balance failure. Okay, so ibig sabihin yung ASB na to, yung AS balance, you proportion the reinforcement such that when the concrete reaches its yield strain, the steel will also reach its yield strain. Kumbaga sabay sila. Okay? Ito yung parang sinasabi natin yung ES. ES is equal to 0.003. Ito naman, ES is greater than 0.003. Okay? Next, let's say dagdagan pa natin to. Okay? Dagdagan mo to. Okay, when your next AS, let's say AS to is greater than AS balance, let's say dinagdagan mo, okay? Increase yung ganun. Ang mangyayari dito, yung concrete crashes, okay? Concrete crashes before AS yields. So, ano mangyayari dyan? Okay? Ang ganun dito, ang failure nito is tinatawag natin na compression failure. Pag compression failure, yung beam mo is brittle. Okay, yung brittle behavior. Ibig sabihin nito, yung brittle behavior, bigla-bigla lang babagsak ngayon yung concrete mo without the steel yielding. Mas delikado to. So, parang tinitingnan, uy, maganda-ganda ba yung beam mo? Wala kang warning eh. Walang warning. So, ang nangyayari yan, biglang collapse. Okay, sudden collapse. Okay, when we say sudden collapse, ito yung pinakadelikado. Okay? Kumbaga parang visually maganda-ganda yung beam mo, pero yun pala, andito siya na condition. Okay, ito yung magpe-fail without warning. Ito naman, yung ES mo is less than 0.003. Okay? So, among these three of design, ang sinasabi ng code, ito, always design yung beam mo in this condition. Okay, always design yung beam mo in this condition such that, sabi ng code, para ma-achieve mo yan, it's either, ito yung strain mo, ES, ito yung 0.003. Para ma-achieve mo yan, ano yung magiging ES? Okay? So, ano yung magiging ES? Now, yung code natin, meron siyang specific condition na kapag yung axial load natin, okay, is less than 0.10 F prime C of the area of concrete. Okay? Ito parang minimal axial. Kasi ang beam naman natin is ang beam kasi is flexure ang dinedesign natin. Okay? Pag ito yung condition natin, sabi ng code, pwede natin gamitin ng ET should be less than or equal to 0.004. Okay, bakit? Why the code recommends that the beam can be designed using ET is greater than or equal to 4? To satisfy yung code recommendation na mag-yield yung bakal. Okay, mag-yield yung bakal or magkakaroon siya ng tension failure. Okay, tension failure and pag tension failure, ang mangyayari sa beam mo is mag-yield bago before yung crushing sa compression ng concrete. Okay? Kaya lang, sabi na code, okay, para ma-maximize, meron pang code requirement. 'Di ba sa tension control, okay, sa tension control section, tension control, ito yung EC na 0.003 and then ito, when ES is greater than 0.005, ito yung parang tension control section natin. Okay, tension control. Now, ang sabi lang naman ng code is, ito yung tension failure. Okay, pwede mo siyang design as when the strain is 0.004 or pwede rin na 0.005. Now, if you want to make your beam fail in tension as well as uh, the mode of failure will be, or yes, is in tension control. I believe that we can design yung section at EET or ES is greater than or equal to 0.005. And this, when your strain is 0.005, ang reduction factor mo is 0.9. In this case, alam mong mag-yield. But if you use this reduction factor, you know that your beam will fail in tension. Okay? So that's why dito, if we are designing, we want that our beam will fail in tension as well as it will observe a ductile behavior. So yun. So meron na tayong reduction factor. Okay, kung walang sinabing condition, okay, sa problem, wala kasing sinabi. So hindi naman niya sinabing i-design natin siya in balance or in tension control. Okay? So, tayo magdidikta kung ano yung magiging behavior ng beam. Pero ang recommendation ng code, at least ang ET is 0.003 or mag-yield. Pero, if we look closely dito sa may strain diagram, if you want our beam to be tension control, kapag nasa tension control kasi siya, region, it magpa-fail na rin siya in tension. Okay, so that's why our reduction factor phi here will be 0.9. So, titingnan mo yung formula, given na to, meron ka ng phi. Ang ano na lang dito is A. So, balik tayo sa given. Ito, meron na tayong MU. So, yung MU is 202.5. Multiply natin sa 6 para maging Newton, mm. Ang phi natin is 0.9. Ang, so, 0.85, anong F prime C na given? 28. So, we have 28. Okay, we have A, ang, tagalin ko muna. We have A na unknown, and then yung B is 250 ata. Ayan, 250. 250. Ang D natin is 500. Kaya lang sinabi niya, ang steel covering is 75 from centroid. So, ibig sabihin, ang total depth ng 500, yung effective depth, okay, effective depth will be H minus 75. So, ang D natin is, okay, 425. So, 425 to. 425 minus A over 2. So, isa lang yung unknown dyan. Okay, kaya na lang calculate nyo to. So, 202. We have 2. So, 202, 0.5 times 10 raised to 6. Okay? And then, equate mo yan sa 0.9. Okay, times 0.85 times 28. Unknown natin yung X. Okay, times 250. Ang D natin is 425 minus X over 2. X over 2. Okay. Kaya na ng calculator yan. So, 100.97 mm. If you want to verify kung talagang so, hindi natin i-check. Basta ito na yung A. Okay? Ito na yung depth of compression block. And then, for letter C, ang gagawin na lang natin is summation forces horizontal is equal to 0. So, yung C is equal to T. Okay, so we know that ito 0.85, F prime C is 28, A is 100.97, B is 250, So we have AS, yung unknown. Now, if we set our reduction factor to 0.9, we know that Fs will be greater than Fy. Or, if this case, ang Fs natin is equal to Fy. So, that's why here, we're going to use yung Fy, which is, ano yung given na Fy? 415. So, we have 415 here. So, ano yung AS natin? So, AS will be 0.85 times 28. So, 1447.64 mm squared. So, tatanungin yung AS natin, required area of tension reinforcement. Now, kung tatanungin kung ilang number, let's say, kukunin mo na lang kung, let's say we're going to use 20 mm diameter. Titignan natin kung ilan yung ilang 20 mm yan. So, we have, let's say, N. So, 1447.6 divided by pi over 4. So, 20 squared. So, ilang 20 mm yan? 0.64. 4 squared. So, 4.6. 4.6. Let's say, gawin natin 5. 5 pieces. Yan, 5 pieces na 20 mm. Okay? So, let's say kung kukunin mo na kung ilang 25, di palitan mo lang to. So, that is how you solve the AS. So, meron ding ibang solution, alternative, sa pag-solve ng AS. Okay, alternative lang naman to. Okay, mas maliit yon, mas mabilis to. So, in terms of coefficient of resistance, nagamitin natin yung formula na to. So, we have mu, so we have phi BD squared. And then, from that, makukuha na natin yung rho, which is 0.85 F prime C. We have Fy. So, 1 minus square root of 1 minus 2 Rn. We have 0.85 F prime C. So, after that, pwede natin makuha yung AS, which is rho BD. So, check natin. So, nakukuha natin yung Rn, which is mu. We have 202.5. So, times 10 raised to 6 over phi, which is 0.9. Ang B natin is 250. And then 425 squared. So, ano yung magiging Rn? Check lang natin. So, Rn will be 202. Mabilisan na lang to. Okay. 6. So, we have 0.9 times 250 times 425 squared. So, meron kang 4.98. So, 4.98. So, megapascal to. And then, masolve mo yung rho actual. So, 0.85. We have 28. We have 415. So, 1 minus the square root of 1 minus 2, 4.98 over 0.85 times 28. Burahin ko lang para clear. So, 4.98. Yun. So, solve mo na to. So, meron ka ng rho. So, yung rho natin dyan will be dapat pares lang sa masolve natin dito. So, pares naman siguro to. So, 0.85 F prime C na 28 okay, over Fy. Okay, 415. So, 1 minus square root of twice yung Rn na 4.98 over 0.85 of F prime C. Okay? So, yun. So, makukuha natin 0.0136. 0.136. So, para makuha natin yung AS, so 0.0136, yung B natin is 250 multiplied by 425. So, meron ka ng AS. Okay, multiply ko lang ito ng AS, 250 times D, 425. So, 1446. Parehas lang yan. So, 1446 point. Sir, sabi mo parehas. Bakit pagkaiba naman? Okay, so, diskumpiyado ka naman pag di mo pa i-consider yan. Okay, AS. Okay, may iba pang solution. Actually, tatlo to. Okay, so, yung next solution naman, in terms of third solution, in terms yung formula pa rin. So, ang MU is, we have free F prime C BD squared omega 1 minus 0.59 omega. Ano naman yung omega dyan? Yung omega na yan is reinforcement index. Okay? Tension steel reinforcement index ng formula is, meron dito sa module dyan. Okay? So, ang rho natin is actually rho, we have Fy over F prime C. So, kung rearrange natin yan, yung rho natin will be omega, we have F prime C over Fy. Yun. So, pag meron ka ng omega, masolve mo na yung rho. So, dito ang unknown lang na meron tayong mu, meron tayong phi. Unknown lang is omega. So, try natin. So, 202.5 multiplied by 10 raised to 6. So, we have 0.9. F prime C is 28. Okay? Multiplied by B, which is 250. Multiplied by 425 squared. We have omega. Okay, 1 minus 0.59 omega. Okay, para isa lang yung unknown. So, magiging omega negative, wait lang. Ito, i-rearrange ko ito. So, we have negative, okay, negative 0.59 omega squared. Okay, plus omega is equal to ito divided by yung itong result na to. If to divide ko dito na result. Ano kaya magiging sagot nun? So, we have 202.5 multiplied by 10 raised to 6. We have 0.9 multiplied by 28 multiplied by 250 multiplied by 425 squared. So, magiging sagot dyan is 0.0, di ko nakita. 178. 178. Okay, isang unknown na lang to. So, we have one mode, ganoon lang to. 5, 3. Okay, mode 5, 3, so negative 0.59. Okay, ito ilipat natin ha. So, i-rearrange ko lang to. So, 0.59 omega squared minus omega plus 0.178 is equal to 0. Para yung standard form nito, ay yung form nito. Wait lang. So, 0.59, okay, minus 1, okay, 0.178. Okay, dalawa yung magiging sagot dyan. So, yung omega mo is 1.493. And then yung omega is yung isa pa 0.202. Okay, 0.202. Now, magiging sagot mo dyan. Okay, ano yung magiging sagot? So, ito, pag dalawa yung sagot, pag ito ang ginamit natin, mapapansin mo, later on, na yung rho mo will be greater than rho max. Okay, ano ba yung rho max? Okay, yung rho max na yan, that is the maximum ratio corresponding to strain is equal to greater than or equal to 0.004 or yung rho natin at 0.004. So, mas greater than siya. Pag ito ginamit natin, okay, mas bababa siya, mag-yield yung bakal. So, always use yung less than 1 na reinforcement index. So that your rho will be 0.202 multiplied by 28 over 415. So, meron ka ng 0.202, bod 1. 0.202 multiplied by 28 over 415. So, meron ka ng rho. So, 0.0136. 136 ba yan? Okay. And then, AS is 0.0136 times 250 times D. So, meron ka ng, multiply ko na lang to, 250 times 425. Oh, uy, 1448. 48.07. Okay. 1448 m squared. Lah, magkaiba sir. Okay, parehas lang yan. Okay. Konti lang naman yung difference eh. 1446, 1448 naman yun. Oh, may ganun. May sobra. Pero ito kasi nag-round off kasi tayo dito. Okay? Pero kung kinonsider mo lahat yan, pare-parehas lang yung sagot. So, either sa tatlo ang gagamitin mo. So, let's say na-compute mo na yung AS. Okay, checking mo ngayon. Okay, pasensya na kayo kung magulo pag ganito pagsulat. Kasi ako naka-prepare ng PowerPoint. Okay, ang AS natin provided is 1446.75. Okay, we have mm squared. Or 144 para at least ganun. Round off na lang natin. AS is 1447. Okay, mm squared. O, wag na to. Yan. Kailangan natin ito, since AS yung nilagay natin, kailangan natin i-verify yan if it conforms with the code requirement. Ano ba yung code requirement? Apply ko lang yan. Apply ko na nga lang lahat. So, AS natin is 144. Ano yung nakuha ba natin sa mechanics kanina? Ay, 1447. 1447.64. Okay, let's agree na lang yan na lang muna. So, dapat ang arrangement natin, since in terms of still ratio, sabi ng code, dapat yung rho min mo, rho actual, rho max, yun. So, dapat, it follows also na itong AS min, and then yung actual, and then, should be less than or equal to AS max. Okay, unahin natin itong AS min. Ang sabi ng code, ang AS min, okay, at least yung provision natin, ang AS min is dalawa yon, yung sabi ng code. Ano yung dalawa na yon? So, yung isa, which is F prime C, we have 4FY BD. And then yung isa naman, 1.4FY BD. Kung ano yung mas malaki sa kanila, okay, whichever is higher, yun yung magiging minimum area natin. So, ito, pag kinuha natin yan, ano magiging area natin? Okay, ito, gamitin natin to. Magiging F prime C, square root of 28 over 4 times 415. Ang B natin is 250 times 425. So, 338. 338.7 mm squared. Ito naman, ang magiging sagot is 1.4 Fy is 415. Ang D natin is, ang B is 250 times 425. 358.43 mm squared. So, ito yung magiging lower limit natin. Okay, for AS min. How about yung rho max? Okay, yung rho max natin, since we set our reduction factor to 0.9, ang reduction factor natin, ang AS max natin is kung saan yung ES is greater than or equal to 0.005. Ito kasing maximum strain when ang factor natin is 0.9. Okay? So, yung rho dito sa 0.005 is 0.85 F prime C Fy. You have beta 1. You have 0.003. We have 0.003 plus 0.005. Okay, so makukuha lang natin 0.005. Kunin lang natin yung rho at that particular strain. So we have 0.85 times 28 over 415. Beta 1 is 0.85. And then, ito pwede mo lang simplify, 3 over 8. So, hindi ko na naman nakita, 0.0183. 0183. Ito yung max. So, yung AS max is 0.0183 times B. Ano ba yung B? 250 times D na 425. So, meron ka ng AS max. Multiply ko na lang to ng 250 times 425. So, 1942.26. So, yun. Ito na ngayon yung maximum. Okay, mm squared. So, ang sabi ng code, dapat yung actual, the provided should be greater than AS min. So, check. And should be less than maximum. Check. So, ito na ngayon yung AS natin.